So in this circuit, what we made was we connected this. Here is a this is a PMOS, okay, and PMOS this connected to a non-inverting input terminal. So to find this here also we need to find what is the V naught here. To find this one, first we need to find whether this is a negative feedback system or positive feedback system. Okay, so why I'm telling only negative feedback or positive feedback, because there is some feedback is going here and there is no current to break this feedback path. Okay, that's why there is a only two possibilities whether this is a negative feedback or positive feedback. Okay, so to find whether this is a negative feedback or positive feedback, let's induce a disturbance as V naught, which is delta V naught, which is positive side. Okay, I'm applying only positive delta V naught, that means it increased. Okay, because of that one, what will be Vg is always proportional to V plus minus V minus. Okay, because of Vg proportional to, because V plus got increased. Okay, so V plus got increased, so Vg, what will do, Vg will increase, V plus increases, so that Vg increases, so that here what will happen, Vg increased. Now this is a PMOS and we assume this is a, let's assume this is in saturation. Okay, so that ISD, that means current flows from source to drain in PMOS proportional to VSG minus mod VTH whole square. VTH we don't have any control. This is a threshold of the MOSFET, and VSG is there. So that if VG increase, that means VSG, what we can do, VS minus VG. So this is VSG. That means VG increased. Because of VG increased, VSG got decreased. If VSG got decreased, what will happen? ISD decreased. Okay, so ISD decrease, what will happen to V naught? Okay, so V naught, so this is V naught, this sorry, this voltage is V naught. So V naught equal to I into, that means ISD into, let's assume this is R. Okay, ISD into R. Okay, so previously we increase delta V naught, and in the first iteration what happened, ISD got reduced, that means V naught got reduced. Okay, so here the disturbance got increased from the reference voltage. So the disturbance was increased in positive side, but by sensing this disturbance, this system what it do, Vg increased, and so ISD reduced. So because ISD got reduced, V naught got reduced proportional to this disturbance, so that this system is in negative feedback. Okay, so this is a negative feedback, and if I consider this is a negative feedback, let's find what is the voltage. Sorry, okay, so because of this is negative feedback, this inverting input terminal and non-inverting terminal input terminal voltage will be same. That means we, because this is a inverting terminal is V in, and non-inverting terminal voltage also will become V in, and there is no current flowing through this one, and there is no resistor, because this input terminals offers very high impedance I equal to 0, and V in is here, and V naught will become V in, so that V naught equal to V in volt, and current flowing through this path resistor will be I is equal to, that means ISD or I load equal to V in divided by R. Why it's happened like this? Because this is a negative feedback system.